What's up, math fans? Today we're doing adding and subtracting radicals. This video actually goes along with multiplying and dividing radicals. Not every number is a perfect square, and if you've ever dealt with the Pythagorean theorem, you deal with square roots all the time. So it is helpful to be comfortable with numbers that are irrational or non-perfect squares. Like radical 3, for example. 3 is not a perfect square, so I can't find the square root of 3. But here's how to tackle these problems without a calculator. I don't want those estimated decimal answers. These are considered exact answers. Some vocabulary real quick. If you're dealing with separate numbers, radical A times radical B, you are allowed to multiply the numbers inside. And those numbers are called the radicands. Anything inside a radical is the radical symbol. Inside would be the radicand, okay? So radical A times radical B is the same as saying radical AB. And you'll see that in a minute. There's a couple other words you should know. There's actually a hidden number right there, a little tiny number right there. That's called the index. And whenever there's no number, you're used to saying, oh, there's an imaginary 1, there's an implied 1. Yes, if I was talking about a coefficient, there's a coefficient of 1 here. But I'm not talking about the coefficient, I'm talking about the index. Index is actually 2, because that is a square root symbol, and a square root symbol means what times itself, what twice gives you whatever's inside. For example, the square root of 25, what times itself gives me 25? That's 5. If it's no number, if you don't see an index, you can understand it's implied that it's a 2, all right, square root. Any other number would actually be there. For example, cube root would actually be there, and what the cube root means is what times itself 3 times, and that's why there's a 3 there. What cubed gives me 8. Hopefully you know it's 2 times 2 times 2. The cube root of 8 is 2. Alright, now I'm going to go over here. Do I know the square root of 3? No. Do I know the square root of 27? No, there's nothing I can do, right? Well, first you should understand that radicals behave the same as variables. Do you know what 2x plus 3x is? Hopefully you know to add the coefficients and get 5, and you keep the variable the same. If there was an exponent on it, then you would keep that the same. As long as they're like terms, you add the coefficients. So if I look here, well, I have the same radical, so that means I have like terms. Again, same rule, I just add the coefficients and I get 5 radical 5. Okay, notice I didn't change the x, you don't change the radicand either. Keep it, it's considered like terms. So when I go here, you can't add the insides because they're not like terms. So there's nothing you can do, you're done with the problem. Let's move on. 18, 8, and 24, again, there's nothing you can do, so you're done with the problem. Or are you? Because if the rule is you can add like radicands, let's see if we can discover like radicands. So negative 2 radical 3, there's pretty much nothing I can do about that. But I can split apart. You see what happened here is something times something you can write under 1 radical. Well, maybe 27 came from something times something. So let's factor that 27. So 27 actually breaks down to radical 9 times radical 3. 9 times 3 is 27. Alright, and I'm going to say this again. Choose the pair with the largest perfect square. The reason 9 times 3 is a great pair of factors is because 9 is a perfect square. Alright, so what's the square root of 9? Do you know it? What times itself is 9? 3, just 3. A lot of people keep breaking it down and they keep putting the radical. Nope, 9 is a perfect square. Square root of 9 is 3. This radical 3 next to it will drop down, and then that 3 will drop down. So now I have negative 2 radical 3 plus 33 radical 3, right? No. This 3 coefficient means 3 times that thing. So this 3 coefficient still means 3 times that thing, and you're allowed to multiply whole numbers together. So this gives me 9 radical 3. So now I have negative 2 radical 3 plus 9 radical 3, and what's the rule? The rule from over here is add the coefficients, keep the like terms, keep the common radicand. So this final answer is 7 radical 3. Alright, we're going to move on, try to do it on your own, and then watch me. So, I'm going to clear some space, and I got 18, 8, and 24, and none of those are the same. So I'm going to try to break it down. Now if I break down 18, my options of factors are 6 times 3, or 9 times 2, or 18 times 1. So which pair do I choose? If you were listening, you choose the pair with the largest perfect square. So that's going to be 9 times 2. Okay? Why? Because the square root of 9 is 3, and I want that. I want to be able to find a perfect square. Comes outside. And then that negative 3 drops down. Of course, I'm going to multiply. Plus, now 3 radical 8. I'm going to break the 8 down. I'm going to break the 24 down. 8, that's pretty easy. It's 4 times 2. There was really no choices there. Radical 4 times radical 2. What about the 24? You got 8 times 3, you got 12 times 2, and you got 4 times 6. Okay? So now everything's going to come smooth. Plus sign, 3 times the square root of 4 is 2, and then that radical 2 drops down. Minus sign. Square root of 4 is 2 again, and then the radical 6 drops down. Alright, so I'm simplifying. Now, simplify some more. So this is negative 9 root 2 plus 6 root 2 minus 2 root 6. It looks messy, just take it one at a time. If this is overwhelming, pretend it's 3 separate questions and do them separately. Now that I've done them separately, I'm going to see if I have common radicands or like terms and combine them. So I have negative 9 plus 6, that's negative 3, keep the radical 2 the same. Alright, so these are my like terms. This, unfortunately, is not the same, so I'm just going to drop it down. Alright, and if I ever get stuck, I can just cheat and look at my tie, which has some mathematical symbols on it. Radicals are very popular, so please get comfortable with them. This is considered an exact answer. If you go to the calculator for any of this, it usually gives you a decimal or a rounded, estimated answer. I want exact, irrational answers. Thanks for watching. See ya.